Savkar, Ravi Savkar. Ravi Savkar, sorry. Is a senior lead engineer at Qualcomm. Yeah, welcome.
Hello everybody. With product owners and we need to have cross-functional teams. So a single Scrum team should be able to deliver everything that a feature requires, right? And next thing is we need self-organizing team. So we don't want the lead or the managers to give, okay, you do this particular job, you need to do that particular job. So we want the team to commit on a particular feature and deliver it at the end of the sprint. And then technical capabilities of the team. So no matter how good the supporting structure is, unless you have the right technical capability, you will not be able to deliver the problem. So this is regardless of Scrum or anything else. I mean, even if you for waterfall to circuit, this is needed. So, right? And then we need to ensure that at the end of every sprint, we deliver potentially shippable product increment every sprint. So here the emphasis is on every sprint, right? So it's not just okay. One sprint we deliver a potentially shippable product increment. We need to ensure that every particular sprint we have something that we can deliver to the product owner, right? So yeah. So in this presentation, this would be our focus, right? So, what are the key components that we would need to deliver potentially shippable product increment? Right? So, first thing is to identify thin vertical slices. So here we need to identify not vertical slices and not the horizontal slices. So basically, in order to deliver a potentially shippable product increment, the slice that we are working on, the user story that we are working on, it has to cut across all the relevant portion of the product, right? So that's when we would be able to deliver a product. And then it needs to be discussed with the product owner, the developer has to discuss with product owner, and the tester has to discuss with tester, the developer and the product owner. I mean, all three has to come into an agreement as to what do we mean by this particular user story, and when we say okay, this is tested and released, is it meeting that criteria, right? And then implemented changes, no need to explain. All tests are completed, so done. And demo to the product owner. And this is where there's the final check whether the product increment is meeting the criteria or not. So here the product owner inspects and see okay whether it meets their expectation. And if it does, the sprint is a success. Otherwise, it's a failure. Right. So now I want to ask the audience. So how many of you here have worked on system software or embedded software? Right. Okay. Great. So one of the challenges that we encounter in system software basically is that we cannot identify vertical slices in embedded software. So I'll just go through the common reasons that we encounter in our right. So user stories are for application development. So here in system software, there's no person, there's no user. So how can I write a user story when there are no users? So the interactions. Yeah, sure.
The team that we were consulting with, so we had given them an example of user login to talk about the vertical thin slices. So if you have an email account and you are using user login, you give the username and the password, right? So that was the example that we showcased to them earlier. And then we said you enter the username and then the password, and then what are the scenarios that you encounter maybe your username and password are incorrect. You need a sign up feature, or you will need forgot password link where you can click and get the password reset, etc. etc. So each of them fit into the vertical slice, thin vertical slice. The team that we were consulting with, because they are all system software developers, they said, you know what, those stories are good for a for software which has user interaction. Our system have user interaction. So coming up with user stories is not our game. So that was the first hurdle that we had to face. So
Yes. We will kind of start with the example that was there. Okay. And hardware dependencies. So for application software, it's easy to develop because everything can be done on FPC. Look, we have limited number of hardware, and if you have to complete all the testing, all the implementation in a single sprint, it is just not possible. And even for unit tests, we would require hardware. So these are the kind of arguments that given. And then system software is very complex, and vertical slice is not complex at all. So uh, for those who have worked on not on system software, so isn't software in general complex as it gets built in? Every software is complex, right? So, but this is the mindset, or this is the kind of arguments that comes in the system software. Right? And then system software development is slow again, right? So in Java, you have if you have parse a string, you just have you use the utilities and the parsing is done. However, if I have to do the same thing in C, with a language which is kind of commonly used for system development, it takes a lot of time because I have to write the code for that and have to test that. Additionally, in application software, there is no constraint of memory. In system software, if I have to declare an array of 20 bytes, I have to think a lot. So yeah, I mean, if I have to write an optimal code and it takes lower memory and it executes it first, it's kind of slow. So, yeah.
So, the people who have used Python, you must have noticed that if you want to maintain a list in Python, you can do it with much ease. However, if you have to do the same in C, then you have to define a data structure and then have a linked relation and we take care of the pointers and the memory allocation, etc., etc., etc. So that's what most of the people say when they say system software development is slower because we have to do so many things ourselves in C. So that's the kind of mental block that the teams get into, and they use that mental block to justify not having vertical pin slices. So that's the point we wanted to make here.
Thanks. So, while some of the reasons given are kind of valid, um, it doesn't actually stop us from creating vertical slice. So, even with all this, even if we assume all these reasons are valid, we still can create vertical slices. So, as a demonstration, I mean, I'll be sharing one of the past experiences in my previous companies. So, a compiler. So we were writing a software for compiler, and I'll be sharing the details on that. Right. So before we start, so let's just have a broad view on what does a compiler software do, right? So this architecture is not inclusive or it's not typical. We're just going to brush up the basic layers so that we'll be able to cover in future slides. Right. So what does a compiler do? So let's say if I write a printf statement, so the compiler checks whether the syntax is correct. So it checks whether the colon is present at the end and the totals that we are using are right. So it does a lot of checking, and it does a parsing of the token. So if you have a for, what needs to be done for that? If there is a int, what needs to be done? So these kind of things are taken care by the parser. Right? And then we have the elaborator. So while the parser does the checking at the line level, it's the elaborator code which has the context of the code that is written. So basically, if there is a assignment or if there is an increment, elaborator has a bigger picture as to what is happening, whether the variable is a local variable, it's a global variable, how to treat that in the statement, logical. These are the kind of things that are taken care by the elaborator, and it understands different data type based on the format specified. And then we have code generator. So this is the assembly code that gets generated. So this most of the time is specific to the hardware and architecture. So you want to add something?
So parser here, this does the token parsing as well. Token parsing. So if you have a if statement, let's say if followed by parentheses, the whole it will read to I and then if and then the parentheses, open parentheses and the closing parentheses, and then validate the string. So that's the complexity level of the parser. The elaborator, it does a zoom out, as we heard in the previous talk. So it does a zoom out and then takes a broader view of the whole code that is being compiled, and then checks for the context of the code and then sees where the variable is declared. Is it the right place to declare, or is it a static variable where memory has to be allocated someplace else, or is it a dynamically allocated memory? Is it a pointer, etc. The code generator is again complex because the entire code that is written by the developer has to be translated into the assembly level language, which has only probably 4 or 5 or 6 instructions, right? So again, all three pieces, though we have made it very simplistic here to look, three different working together modules. All three are very very complex. So this is the the team that was working on developing this compiler, and then we were trying to work with the team and then have vertical things as identified so that they can have a potential product increment at the end of every sprint. So the new feature that the team was asked to implement, there were a couple of requirements given. Pre-process printing of a text on the display. So this was one of the asks. The second ask was print the variables also on the display. So first one is the text and then second one is the variables. Third one was print all these things to a file. So please interpret in case you want to ask. So the team said we will need 12 weeks to deliver this feature. Now we had 2 weeks of sprint, and then we said no, we cannot wait for 12 weeks to have a fresh look at the software, because we're not sure whether we're going in the right direction or we need some meetings, etc. Right? So that's when the initial approach of the team said is, okay, if you cannot wait for 12 weeks, we will break down the tasks and have incremental deliveries. So we asked, what is it? The team said, this was the initial approach the team came up with. We will implement a test, pre-process printing the text, only the text, no variables are going to be supported. If we say print hello world, we will get that print, that's all, we will accomplish it. So they said it's going to be 2 weeks of effort. Given the complexity, yes, it is a 2 weeks effort, so we said, yeah, that's good. Followed by the sprint 2, the team said we'll get started with implementing the variables as well as the text printing. Sprint 3, the same. Sprint 4, the same. Sprint 5 also the same. Because this is where most of the complexities stay, right? You have different kinds of variables, different complexities involved. So that's when the team said, no, this is impossible to break up. We will need these many sprints. And what the team meant is, at the end of these sprints, we will not showcase anything for you. Give us 4 sprints, which is 8 weeks of time. At the end of 8 weeks, we will come and showcase something to you. So this is what we were dealing with. Okay. And finally, at the end of the sixth sprint, again we will deliver this file, printing to a file. So we were okay with sprint 1 and sprint 6, but we were not okay with the 4 sprints in between, at least from the initial approach the team came up with. So, as I said earlier, also there were a lot of hurdles the team kept in front of us. They said, no, you guys come from application development background, you don't understand systems of development, you don't understand C, you don't understand that, you don't understand this. We said, everything, all that is fine, but let us get down and start discussing with what you can provide us with, or what is it that you are trying to solve in these 4 sprints.
Just a previous slide. So, I mean, the sprint to sprint is sprint 4, sprint 5. So, how, I mean, here the only data that we got from the team is that we'll be doing this. So, there was no elaboration given, and I mean, there was, unless we did a conversation of give us the details, we did not get any more details apart from this. Yeah.
I think naturally the team was trying to close the doors on us, saying no more discussion on this, this is what we want to do. So we had to really struggle to get the team to open the door and then let us in, and then we started discussing with them. So the big feature or 4 sprint spanning feature, the user story went like this. As a coder, I want compiler to pre-process printing variables on display. Okay. So obviously, if you look at this user story, it would occur that it takes longer duration to implement. Now, how we can break this into thinner slices? What are the supported syntax? So we went to the team and asked them what are the syntax that are going to be supported. So then the team gave us all this. So if you have this kind of a statement, it will print a character. If you have a series of characters, we'll support that as well. If you have an integer, we'll support that. You have a boolean, we'll support that. You have a combination and then the string also. String is a collection of characters. So we'll support that as well. So these are the 5 or 6 different possibilities that we're going to support at the end of 5th sprint. That's what the team said. So now we went back to the team and asked, now if you're implementing only this, the first one, character printing, and if you're not going to implement anything else, only this, how much time it might take? The team said more than a week, maybe 2 weeks. So we said, why don't you give me only this? Then again there were discussions like, when we are going into the parser code, we will as well make all the changes. Because parser will do all these things. We can do all of them together and then go to the elaborator and so team was getting into the horizontal slicing mode and we were trying to bring them into the vertical slicing mode. So then we said, hold on.
So basically, another conversation that came up during this discussion was, okay, I understand that, see, at the parser, all I have to do is for integer and characters, passing is pretty much the same. So I can take that. So parsing part I can complete in 2 to 3 weeks. So at the end of second sprint, I would be able to deliver the parsing part. But I mean, when we challenge them, okay, why is that we can't give only this portion of the code and deliver it to us? We got a lot of technical hurdles. So basically, the build takes a lot of time. It takes 2 to 2.5 hours. So that is I mean that increases to the effort that we put into bringing this feature. And even the testers, I would have to rewrite some of the test cases if it is given in parts. So some of the challenges that came up had to be converted to a technical task and basically to reduce the build time and reduce the check-in and check-out complexities. Yeah.
So then we went back to the product owner and asked him, product owner, if we deliver the first one at the end of sprint 2 and deliver this probably combination at the end of the subsequent sprints, would you be okay with it? He said, as long as I can take a look and give a feedback to you, I'm still fine. So then we went back to the team and said, you know what, this product owner also is okay with having this as a deliverable at the end of sprint 2. So why don't we go ahead and start implementing that? So the team was still telling us, Priyank, you don't understand the parser. The parser, if you are implementing, you implement all of them together. So I said, that's still okay, but you do everything, whatever you want to, but give us this at the end of sprint. Then this or this combination of two at the end of sprint 3. Then we'll start discussing. So that's how we went about. And then we came up with user stories like this. So before breaking the user story, you all had a look at it earlier. It looked like this. As a coder, I want compiler to do all things. So this was the initial user story. And after breaking, we had 6 thin slices. So you could, as you could see, we were having printing a character as one of these. Only that was achieved. Then the team went on to printing a set of characters. Then the team went on to printing the integer, getting the integer printed. So all this thing had to be supported in the compiler, so there was a lot of pre-processing work needed to be done along with this. So the comparison of the thin slices. So before breaking, it was a big story, and this is how the sprint looked like. And our focus was in this red part, which we were not okay with.
Go to the previous. So basically, this is this is one way of cutting into the vertical slices. Actually, printing. The work that was involved was more complex. Some of the things are not captured. So when we say print a variable, it involves printing a local variable, which is here in the stack. It involves printing a global variable, which is in the zero and ZI data, which is stored as ZI data. And then if it is a register variable, it has to be picked from register variable. So basically, there are a whole lot of complexities which we have not captured here for simplicity. But this is not when it comes to compiler, a simple thing that appears as one syntax takes a whole lot of code at the back end to be processed.
That reminds me, just printing the character. One of the engineers actually sat down with me and then showed to me like what all complexities are involved. So if it is a static variable, then we would have to have a reference with a different place in memory where to reference static variables. If it is a dynamically allocated memory, then he has to reference it from different place. So these are the level of complexities that the team was dealing with. So we even got into discussions, as Ravi brought it up. So we even got into discussions asking the team, why don't we just print the static variables once, or why don't we just print the dynamic variables as a product increment? But then it never worked with the product owner, so we had to settle down to this, and we could actually pull it off with these suggestions. And the pivot point we used here is the data types. So each data type, if it is a character, the compiler code takes a different path altogether to handle character variable. Similarly, if it is an integer, the compiler path takes a very different path because the character would normally occupy 1 byte. However, if it is an integer, then it's like 2 times or 4 times the character variable. And when it comes to Boolean, it's just a small bit. It's not even a byte. So then again the compiler takes a different path altogether. So this is the complexity that we were dealing with. And so the stories. Okay.
So then this is the initial stories that were given. Okay. So after breaking up, okay, since sprint 1 and sprint 6, I mean, we did not have any problem. It was delivered in a single sprint, so it was fine. So at sprint 2, that's when actually bulk of the work got done. So even though we are just printing a character, a lot of changes in parser and generator code and the elaborator had to be done. So at Sprint 2, the team said, okay, we can just deliver the character. And then printing a set of characters. So since we have the character in place, it would be easy for us to pull out these three user stories as well. So printing of set of characters, printing of integer variable, and in printing of boolean variable, right? So these we were clubbed for sprint 3, and in sprint 4 we were able to print. Okay, this has to be a string. Okay, so this is for printing string, and at the final sprint, the entire combination was delivered. So you print a character, you print a string, everything was delivered in the final sprint. Right. So this is the this is one of the case study that we have brought in, and the same things are applicable for any other system software. If not for compiler, if you're running some, if you're program on IoT or beacons kind of thing. So similar things are similar kind of sets, similar mindset is needed for systems.
Yeah, so any software engagement that we get into, as especially consultants or agile coaches, we will face similar hurdles. So we thought, this is a very good story to share with the community, because there's a lot of parallels. I'm sure many of you have seen similar hurdles or similar block minds, especially when it comes to having vertical thin slices. So if you have any questions, probably we can. Yeah.
Have the issue sometimes when you break up the stories, and probably if it is very technical, it takes a lot of challenge. Two things I want to understand. One is what kind of impact analysis was like. You said that they had a bit of dependencies there. So when you're doing, sometimes you have a lot of dependencies, right? So did any impact analysis for all that, as you said, with the developer or particular person? That is one. Second is okay, once you were done with this, so sprint on time, how were you sure that this doesn't did anything break out? Because it looks like such a story, but did anything break out?
Oh, yes. So the first question is how did the dependencies work, right? So the parser team initially when we got into the discussion, any changes in the parser code had to be approved by a team sitting overseas somewhere in Europe. So that was a very specialized team. They would take a detailed look at every code that you have written and then approve. Only then you could check it. And that team was actually very constrained because they were getting requests from all across the world. They had a very specialized team. So that was something that we had to deal with. And we had to talk to the management team, and then the management team had a word with the parser team's management team. So they said, we are going ahead with this approach. Let us see the benefits of this. So we need your full support. So that team came in with the full support. And the other struggle that Ravi actually earlier mentioned was that the code commit and then the code commit readiness and all were taking longer durations. So that was another hesitation from the team side to do multiple commits, code commits. So they used to say like, if I have to commit every now and then, anyways it's a waste of time. So let me do everything upfront and then commit. So this is the behavior that was driven basically by code commit duration being long. So we had to work with the support teams to get the code commit time shortened. It took a while. We couldn't do it in those 6 sprints at least, but it took a while. And did anything break? Yes. There were times when teams said, we should have gone back to the earlier phase wherein we do every changes in the parser and get the parser changes reviewed from the team. Right? So team were like kind of giving up, almost at the end of giving up, verge of giving up. But then we had to, get the management team to talk to the team, management to talk to the team, and then say, you guys, let's hold on. Let's try and run this through fully before we judge. So those are the challenges, real life challenges that we had to face. No. At least the sprints were not cancelled. The team were actually capable enough, so they could actually do it. But somehow they had this mental block of so many constraints that they were not thinking this through. And when they were forced to think this through, they could really pull it off.
Like the problem, perhaps at just a certain problem, the team was growing. So I'm just curious as to why then the team or the stakeholder who invited you guys to come and get the team on that track.
Oh yeah.
Why did he again restrict us the use case for the team?
Okay. Yes.
So if the same like process like I told them there was something to execute after that. In our case, I think
It was a potentially shippable.
I can't shake off the feeling that perhaps you were a little dogmatic about having a potentially so it's hard to shake off that feeling. Perhaps you can.
Yes. So we were really, you got it right. We really stood our ground. The question is, why were you called in the first place to work with the team to identify vertical things like this? Was there any problem that the team was going through? So, let me talk about was there any problem with the team? Yes, this organization that we work with, they have presence across development centers across the world, and a couple of different country centers had embraced agile practices, Scrum especially, and they were seeing a lot of benefits. And the main complaint about the teams here was that they have not embraced agility, and because of which there is a misalignment across the organization. So they wanted to do a trial with one particular team, and before scaling it across to all the teams in India. So that was the primary reason. So now when we went in and then we saw that we looked at the practices, and when we introduced the Scrum approach of working, we really stood our ground. In fact, let me go back to that slide. So to get the benefits of Scrum, right? So let me go back. Yes. So we told the team that Scrum is a transformation. We told the management team that Scrum is a transformation, and it demands a lot from you all. Unless and until you are game enough to do everything that is required to make it a success, to get all the benefits from Scrum, you will not want to see much benefits. You would as well go back and say, you know what, before doing Scrum, we had this productivity or we had this releases going out with this such a quality. Even after Scrum, we are doing the same thing. So why do stress ourselves with this transformation? So we told the team, the management team, that unless we do all this and we go through all this pain, we will not see the benefits of Scrum. And we held our ground. We really were hell bent on having a potentially shippable product implement. And one of the reasons is the product owner had a complaint on all the teams saying, you know what, I go to the team and I give them a requirements document, and it looks like they go into a cave for 6 months or 8 months, and then they come back and show me, okay, this is the product. When I look at it, it's only 40% of what I have asked for, and 60% is what not I have asked for. Something that the team increased the scope on their own, and then they worked on it. They said, you know what, the scope has to be increased, otherwise we'll face that problem, this problem. Most of it goes over the head of the product owner. He couldn't really fathom it. So that was the main complaint of the product owner. So we said, Scrum has a solution for you. Every sprint, we will have a potentially shippable product increment that will be showcased to you, and you can give a feedback to the team whether they're in the right direction or not. Whether they're really whether really working on value addition or they're just increasing the scope because they thought it will be useful to the customer. And there was an internal study also made, just saying because it came up, there was an internal study made as to how many of the features of the product are really being used by the customers. It was 40%. 60% of the features were actually not widely being used or being sparsely used. So it reduces a lot of slack, it reduces a lot of budget, it is requiring so many benefits to take. So did I answer your question? Yes.
So, we have 6 sprints here, but was there any other work done before you went top of the sprints? Some sort of, like we have in the previous system thinking, some sort of architecture, design kind of work?
All this were done. Actually, in fact, this compiler had already been implemented, it was doing so many other stuff. This was a new feature being added to the compiler, the software.
But the architecture, design, and impact analysis for all this new additions, was that done? I assume that was done in sprint 0. Then you pick up sprint
environmental and framework.
The way it worked is, they were kind of working in the waterfall model of this file, and then we started working with the team, and that's when we had to, come around some deviation in the ways they were working. So some of it actually, as you said, they were done earlier, analysis and all that.
Basically, when we started, we had the team had an understanding of what it should be.
Yes.
Just wanted to add, based on Scrum guide, it has been revised. It is not shippable now, it is releasable.
Feasible.
It is potential releasable production.
Yeah.
What's the difference? See, what we started to do is we can ship the product, but it is not releasable. It goes to equity, but it is not releasable. We can have some defects in it. But that is the reason. It was moved from shippable to releasable. That's the only production. And that is why I had to do it.
So how many of you did see a parallel in an organization that you are working with? It's good to know. Alright then,
This is not just with the system, even otherwise there are something called technical stories.
yes.
Like, okay, as a user, the end user is not a customer but a technical insider. So even there it's the same thing.
Exactly. Yes.
In fact, some software is not very different from
Yeah.
the other software, but the mindset is the places where we have